In this video, we're going to take a look at arc length and area of a sector in degrees and in radians. So arc length and area of a sector can be found in degrees or radians because degrees and radians are a measure of the same thing. It's just in a different way to measure it. So the length of an arc subtended by a central angle can be expressed as a fraction of the circumference. The area of a sector subtended by a central angle can be expressed as a fraction of the area. It's like you're looking at a piece of pizza and you're either finding the area of the pizza, which is the area of the sector, or you're finding the length of the crust of the piece of pizza, which is like the arc length. So something to keep in mind that's very important is a whole circle measures 360 degrees, and in radians that would be 2 pi. A half of a circle is 180 degrees, or 1 pi. So our formulas are very similar. It just matters if you have degrees or if you are given radians or you're looking for radians. So it's set up pretty much the same way other than that. You have a fraction of the whole circle in degrees times the circumference is arc length in degrees, or you have a fraction of the whole circle times the area of the circle to find the area of the circle in degrees. But then it's the same way with radians. If you're given radians, you just have to make sure you divide that by 2 pi because that's how much a whole circle is worth in radians. But then when you set this up, you have theta divided by 2 pi times the circumference of the circle, which is 2 pi r. And if you notice, 2 pi in that case would then cancel out. So this formula simplifies to just be s equals theta times the radius. So it's very simplified after you reduce it a little bit. The area of a sector works very similar to the area of a sector in degrees. So you have the central angle in radians divided by the total amount of radians in a circle, which is 2 pi, times the area of the circle. And then you can always set it up that way, or if you wanted to, you could reduce it to be s equals theta over 2 times the radius squared. But either way would be fine. So let's just take a look at a couple of examples. So we're going to look at the odd numbers, and then together in class we'll look at the even numbers. So number 1 says find the length of arc AB. So all you have to do is notice this is in degrees. So I'm going to need the formula for degrees. So I'm going to say S for sector is theta over 360 because that's the important part of the formula. If I have degrees, I need to use the fraction out of 360. Because that's how many degrees are in a whole circle. And then I'm going to multiply by the circumference of the circle, which is 2 pi times the radius. So then let's use theta is 120 degrees, because that's our central angle that we were given, divided by 360, and then we just have to multiply that by 2 pi times the radius, and they've given us the radius is just the 6 centimeters. So from there, we just have to simplify it. You could type it in the calculator to simplify it. So what is a good way to do that is, let me show you. You can type in your calculator everything and just get a decimal. So sometimes that's appropriate. And sometimes you want to leave the pi as part of your answer because maybe you can see that the answer choices include pi. So if that's the case, you can divide everything and multiply everything and just don't type in the pi as you type all this in. So I'm going to type in 120 divided by 360. I'm going to type in times 2 times 6, but then I still have pi as part of my answer. So let's see. I need to multiply that by 2 and multiply that by 6. So I just did not type in the pi, and that leaves me with a total of 4 pi. Or if my answer choices are decimals, then I can just go ahead and type in 4 pi and get the decimal. So either one is a good answer depending on what your answer choices might be if you're given answer choices. All right, so that would be it for that one. Number 3 says a circle has a radius of 14. So let's write r equals 14 because they've told us the radius. And a central angle of theta equals pi over 2. Find the arc length in radians. So arc length in radians, if you saw at the top, really reduces to be a very simple formula. So you just used to use S equals theta times R, or R times theta. So S equals theta times R, which would be pi over 2 times the radius, So then we just simplify that, and I would say that is 14 pi over 2. And then that would just be 7 pi. And then if you need a decimal, you could just get that with your calculator. So I could do 7 pi in the calculator, and I would get 21.99 if I need a decimal. But that would be it for number 3. Let's take a look at some more examples on the next page. So number 5 says find the area of the shaded sector. So again, I notice this is in degrees. So I'm going to use 90 degrees over 360 degrees, because if it's out of degrees, I've got to use 360. And then I need to find the area of the shaded sector. So I need to multiply by the area of a circle formula, which is pi r squared. And then let's just replace that r with what we know the radius is based on our picture. So I can see that the radius would just be equal to 16. So I'm going to put that in for the radius. And then again, we can use our calculator to help clean all that up. So I'm going to type in 90 divided by 360 times 16 squared. But I'm just going to leave out the pi because I want to leave my answer in terms of pi, which a lot of times they do it that way. But if I need a decimal, I can easily just multiply the 64 times pi in the calculator, and I would get a decimal version of the same answer. So 201.06, I'm going to call it. But then that's it. So we're just practicing formulas, basically. It's just that you have to divide by 360 if it's in degrees, or you've got to divide by 2 pi if it's in radians, is the main idea. So number 7 says, given that the measure of angle AOB is 2 pi over 3 radians, and the radius is 18 centimeters, what is the area of the smaller sector AOB? So it's important they did tell us they're looking for this smaller one. And then this is 2 pi over 3. So we need to figure out the area of that sector. So the sector would be the angle, which is 2 pi over 3, divided by the total amount of the circle, which is 2 pi. And then we have to multiply by the formula for the area of the circle, which is pi r squared. And then we know the radius is 18. So I'm just going to rewrite that a little bit. So 2 pi divided by 3 is already a fraction. So instead of dividing by 2 pi, we can multiply by the reciprocal to help fix the complex fraction. So I'm going to multiply by 1 over 2 pi to fix that. And then I'm going to fill in pi times the radius squared, which is 18 squared, since my radius was 18. Now let me just scooch this up a little so I have a little more room, and then we just have to clean all that up. So we have 2 pi at the in our numerator, and we have it in the denominator. So those are actually just going to cancel out. Then I end up with 1/3 times pi times the radius squared. So let's see, 18 squared is 324. And then 1/3 times that, and I can just grab that number in my calculator. So I get 108 pi if I need it in terms of pi, or I can multiply by pi and get a decimal. So I'm just going to type that in and put that as another option. They mean the same thing. It's just sometimes on a test, they'll either get a decimal or they'll get it in terms of pi is what we call it. So in terms of pi is like this answer. And then this is just a decimal, as you already know. So if they say leave in terms of pi, you want to type everything in your calculator except for pi, and then write the number you get with your answer, like with pi included in your answer is what I'm saying. Okay, so one more. Number 9 says a dog has a 20-foot leash attached to the corner where a garage and a fence meet. So here's this leash of 20 feet. So that looks like the radius in this case. And then it says when the dog pulls the leash tight and walks from the fence to the garage. So they're walking from the fence to the garage. It looks like arc length is what they're describing there, because it's not the area. Looks like the arc length would be 55.8 feet. And it says when the dog pulls the leash tight, they walk that far. And then the question is, what is the measure of the angle theta between the garage and the fence in radians? So we're looking for theta. We have arc length and we have the radius. So we can just use that really nice simple formula. S equals theta times the radius. Because remember, our formula reduced to be that nice little formula. So the arc length we know is 55.8. So that is the S. We're looking for the angle theta. And then the radius was 20. So then once you get that set up, all you got to do is divide by 20 to get theta by itself. So I'm just going to type in 55.8 divided by 20. And I get 2.79 is my central angle of theta. And that's it for arc length in radians.